Hi, my name is Paul Nelson with EggerRotork Pumps North America, based in Juliet, Georgia. And today we're talking about the Iris valve here at Upper Blackstone, including the ABB thermal mass flow meters and the Rotork actuators. This was part of an upgrade on the aeration system here. And the Iris valve is a centrally closing orifice that moves to the center, so it's got a center access. And what we do is we use that access to mount our flow meters right in the center here to gain the best accuracy and repeatability possible. Now this project entailed 28 valves. You'll see that there's 4 10-inch valves. I believe there's 16 4-inch valves and 8 5-inch valves on bioreactors 1, 2, 3, and 4. The flow ranges go from a max flow rate of 4160 down to about 740 for the 10-inch valves. And then on the smaller valves, you can see it's 690 down to about 250 or 280 SCFM. Now, the Iris valve, like I said, is a centrally closing orifice. It's flanged. In this case, this one is carbon steel, so it's painted. In your case, it's stainless steel, so it's not painted. You'll see there's a scale on the side that measures percent flow or percent open. There's a stainless steel cover here that we'll talk about for maintenance. And then the Rotork actuator. Our application is for aeration flow control in your wastewater treatment plant. We sell this valve based on energy efficiency, but really the goal is to put the valve in to give you better process control. The ideal situation would be plus or minus 2% accuracy and repeatability. Repeatability being most key. What we'd like to see as a result of your upgrade is that, say you're running at 400 SCFM, suddenly you got to run to about, say, 80% open up to 900 SCFM. When you go back to that 400 SCFM point, that it is still at that same point of opening. And that's the goal. Our valve, I have a video animation of how the valve works. And you can see it's centrally closing. And see the body here, shown in red, actually rotates. Precise, energy savings, low noise, maintenance free, available in sizes 1 to 16 inch. Now, we market this valve with Rotork actuators, but very often we also sell it with a hand lever, either that or with a hand wheel, and then electric actuators, and recently sold one to City of Las Vegas with a pneumatic actuator. And what we're doing is selling the idea of centrally opening, full port open, running most open valve, and you want to run this valve preferably at about 90% open to gain the best control, accuracy, and lowest pressure drop. And the way we design this valve is we look at the static pressure of your basin, and we call that pressure static. And that number, say it's 18 feet, divided by 2.31 is roughly about, what, I think 7.8, 7.9 PSI. And then we design it for Q max and 0.15 PSI pressure drop, Q design, and Q min. And then as the flow increases, your friction loss increases, and that becomes P dynamic. And it's those two that's important, because that relates directly back to the pressure of the discharge of the blower. Now, our valve has a linear flow control. And everyone talks about CV value. Well, we really regard CV value as having very little to do with what we do. What we're looking for is that at 20% open, and following this green line right here, at 20% open, you get 20% flow. At 55% open, you get 55% flow. And at 90% open, you get 90%. Now, we are not perfect. And so we follow this blue curve right here. The green is theoretical. And then we have this thing called gain, which is very important, and that has to do with the range of control. And that gain is those red lines right there. And our ultimate goal with your system is to take your DO level from, say, 2 milligrams per liter and lower the set point down to 1.5 and giving a tight control range. Now, this is an example that took place in Berlin, and they were running at 2 milligrams per liter DO, 2.5, 1.5, 2.5, 1.5. And we were able to come in and lower that set point from 2 to 1.5 and then give them that tight control. And since then, they've run down and they're running at 1.1 today. So they've got very good precise control. Now our valve, this is a functional training session. So now I want to talk about the internal components of it. Okay? Our valve rotates. The body rotates. So it's got a little lever here that comes up to a spindle nut. And that spindle nut is drawn across what you could think of as a rack and pinion. And it turns the body, opening and closing these segments. And again, there's that video I showed you a minute ago. But I made this video with my iPhone. It's really quite basic, but I think it helps to show how the valve works. And I would point to these cam slots here. See the cam slots? And see that cam or follower? Now, the blades or segments are concave and convex, so they ride on each other like a channel, okay? But they're low pressure. This valve is designed for 90, 95 PSI or less. However, what's doing the work here is by turning the body, it's spinning this so that that rotates along that channel. And let's take a look. Well, there we go. Any questions before I go on? Okay, good. I find those videos are very helpful because intuitively we want to know how it works. And here's a cross-section of it that shows that spindle assembly with the spindle nut, that arm or lever that takes and pulls and moves the body, the scale that I spoke about, and then the Rotork actuator. And so there's not a lot of parts. You've got the two body parts, which is the two flange sections. You've got the center body, and then you've got the actuating ring, some O-rings, some spacers, the spindle actuator, and the electric actuator, the Rotork. This is the same view, just looking at it different. Same diagram, looking at it different. And here's the internals. And more importantly, these segments are blades. Those cam followers, and these are the bars that ride into these slots right here on that center body. Now, we do have a set of O-rings, and the O-rings are a wear part, and most often we see wear on these lasting 15, closer to 20 years. So it doesn't see a lot of wear. It's not a static O-ring, it is sealing, and as that body is rotating, it's rubbing, but there's really no pressure against it because we're running very low pressure at about 9 PSI. And so we typically have very little maintenance, and if you had maintenance, you'd be replacing those O-rings. Closer view of that. Now remember, that's concave and convex, so it rides on itself. And that's the spindle assembly. The spindle assembly that we're running here at your facility is bronze. Bronze is what we've been running since 1959. It's tried and proven. It does require a sim-lube greaser. We'll talk about that. We'll speak about the greasing and the maintenance of it. But it works very, very well. We do have new technology out there that's a peak nut, and we've had it beta tested for three and a half years now with good success, although we've had some problems at your facility. So when the spec was written, we had specified peak nut, and after I had the third failure here, I made a decision to switch you over to the bronze that we know that works, because we want to know that on Sunday afternoon when we're watching NASCAR that we're not going to get an emergency phone call that the valve is down. So we made a decision. Now, this is that scale that we spoke about right here. That's mounted up here. That's the cover, the spindle assembly. And here's a typical plant. In fact, we've got over 500 valves installed in North America, and this is just a sample of some of the installations we have. And this is a picture taken in Germany. You'll see the egg-shaped digesters in the background. You'll see that it's painted. In the US, we had standardized on 316 stainless steel. We want it to look good since it's sitting outdoors. In Germany, they tend to do painted carbon steel. Now, if it's okay, can I move on to the thermal mass flow meter?
Are there any questions on the valve?
Okay. There is another slide that I have that seems to be missing that talks about the sim lube greaser and the greaser maintenance. So I would like to follow up with that when I'm done with the flow meters, if possible. The basics of a thermal mass flow meter is it delivers the mass flow of the gas and the volume at normal or standard conditions. And all we're doing is comparing normal conditions to your conditions as the airflow is going past that sensor. And we're looking at a comparison where we have a gas temperature sensor here, and then we've got a control constant that's electrically heated. It's a platinum sensor, and then it's a comparison of both the density and the temperature going past those plates that very quickly calculate what your mass flow rate is. And we look at that as a percentage of flow rate and velocity to how much current needs to be added. And all I'm saying is, if the air is going by slowly, you may not have to add a lot of heat because it's not pulling heat away from that platinum sensor. But as that velocity increases and the flow rate increases, it's going to draw the temperature down, and the controls are going to say, oh, heat up faster. And that's what we're measuring, and that's how we get our accuracy. Now, it's a direct measurement of mass flow. It's got a very broad range of 1 to 150, and it's got a very low pressure drop. Now, we mount it directly in the center of the iris. And so that's where we have our best and cleanest flow and our highest velocity, and that's where we get our best accuracy. Now, we use it for gases. That's all we use it for. I don't know if you can use it for any other application, but my application is just for gas. So we want to keep an eye out for condensation. We worry about dirt, and we look for straightening the flow in front of it, roughly 10 diameters. Now, when we were designing your installation, you were very tight on space. And most of your installations are 10 diameters upstream from the flow meter. So as the flow is coming to the thermal mass flow meter, you have 10 diameters. There are 1 or 2 installations where you turn a 90-degree elbow and you're only going 6 diameters. All you sacrifice is some accuracy. And what we did was we set it up in a factory trial and compensated for having only the 6 diameters so that you wouldn't really notice any change in accuracy. We need to know the composition of the gas. It's low pressure air, it's blower. The temperature is very important to us. You know, so when we were sizing and selecting these things, whether it's 250 degrees or 100 degrees, it doesn't matter. We just need to know when we calibrate it for what temperature to calibrate it to. In your case, I believe we calibrated it to 155. The internals of the flow meter are, see the 2 plates that we spoke about? One being platinum. Well, you've got the sensor element, you've got the sheath, and the internal wires in the capillary section there. And so you're just adding heat to one to compensate for heat loss in the other, and the 2 are just reading off each other. Now, back here it says response, quick response. What is quick response? Well, some of the manufacturers tout 1 second response time. ABB advertised a ½ second response time. For our process and for what we're doing, that's very accurate. We don't really feel that we need to be any faster. So, And we mentioned dirt. We mentioned moisture. The only maintenance involved here could possibly be cleaning it once in a while. And so instead of just supplying a typical thermal mass flow meter here, we also put in a ball valve assembly, which I might have a photo of. Maybe not. But there's a ball valve here. And what you do is you can take and loosen up and remove those 4 bolts. You pull the flow meter out halfway, you turn the ball valve closed. And now that system is isolated. You can take the flow meter out and service it. Simple cleaning. It's set at the correct depth. It was set by us. So when you purchase these, everything was preset. We built the pipes. We did final assembly down in North Haven, Connecticut, and then shipped them up here. And the reason we did that was because we wanted to maintain the correct depth here so that we were in the center of the pipe. You cannot rotate it. Physically, you can rotate it, but you have to have the direction right on the flow meter for accurate measurement. So bear that in mind. Let's see. Oh, every one of your flow meters was calibrated and you were given a calibration certificate. In the future, if you have problems with the flow meter, when you have problems with the flow meter, because everything always goes bad sooner or later, we need to know the serial number and if you have that certificate so we can recall exactly what it was set up for. That's very helpful. Here it is. Here's a picture of one of your installations. See that hot tap? That ball valve assembly? See this ball valve assembly? So you would remove this. Now, you have a remote display that's sitting over here. So that's just a junction box. So you would remove those 4 bolts, lift it up halfway, close the ball valve, then you could service it, insert it back in, open up the ball valve, put it back in place and bolt it up. Here's the remote sensor. That's that ball valve assembly that we spoke about. And that's what it looks like close up. And that's a procedure. What we did was we gave you training manuals so that you can have these slides. And then you have our submittal package in an O&M manual that should show all of this stuff and a procedure on how to maintain it. It's been my experience these require very little or no maintenance. If it's responding, if it's working, I don't really see a reason to do any maintenance on it rather than just check it once a year. We provided an O&M manual. This is the front cover. Here's the table of contents, system components, including the flow meter, the valve, the actuator, local contact names, including our names, safety considerations, and then the manufacturer's instructions, wiring diagrams, shop drawings, and everything. If you don't have this, please let me know, and we'll get another copy to you. Oh, there it is. See, here's a description of the valves: 16 4-inch, 8 5-inch, 4 10-inch, 28 actuators. Here's our address down in Macon, Georgia. Local services, Aqua Solutions. Okay, the next 3 slides show materials construction. Then a procedure for lifting, and then proper mounting without stress. In your O&M manual, you have this page, and you've got this. Now, I don't know about you, but I don't really understand what 1.4435 is. I can Google it. But what I will tell you is that it's a 316 stainless steel body. The segments or the blades are 316L. The spindle nut is bronze, and the spindle guard is 316. We do have a specific lifting instructions. On the smaller valves, you can actually grab it behind the flange and pull your ropes around or your straps and lift it up. And that's good to like 1 inch, 1.5 inches, and 2 inch. Well, we don't have any 2-inch valves here. Our smallest one is 4. So right here, 4 to 12, you'd want to take and attach one of the straps to a bolt here, and then the other strap could actually kind of wrap around this neck that holds the actuator, and then you can lift it. We've had customers that will put the strap through the center here, and then they bend the segments or blades. Please don't do that. Tension-free mounting. When we go to the job site to do startup, the first thing that we do is we look for tension-free mounting. On the smaller valves, 1, 1.5, 2, 2.5, and 3 inch, we want to be about 2 diameters from the valve. We want to have a good support. On the larger valves, we want to be 1.5 diameters or 1 diameter. We've been here, we've started up your valves, we've approved your installation. So they're not all perfect. They're not all within 1 to 1.5 diameters, but we felt that the piping was sufficient so that we wouldn't get any stress on those flanges. And here's an example of working on the Rotork actuator. And this is that cover assembly that houses the Simloop greaser. And that's that spindle nut in bronze. Now, you would take this plug out and you could screw in the spindle nut. And we have a YouTube video that shows you how to do that. Or, here it is right here. The spindle nut moves back and forth on the spindle. And so the Simloop greaser moves back and forth. It's a gas charged greaser. You can buy it from Grainger or some kind of parts house for $50, $55. And this is that YouTube video I mentioned that you can click on. If you just put in Egger Iris Simloop, it comes right up. And it gives instructions on how to do it. Really, essentially what we're doing is, this is a sealed device and it's gas charged. So the first thing you do is you take a knife and you cut off the plastic end. So now the grease can flow. And then on the back side here is a dial that you get in with an Allen wrench and you set for 12 months. And then once it's set, then you can just screw it right in to there and you're done. Now when I do maintenance, the way I do it is I'll come along and first thing I do is I open up the standstill cover and I clean off all the old grease here. Because what I find is in cold weather events, that grease gets hard. We start to trip out on high torque. So once a year, I go in, I'll clean that up with a rag. I'll shoot some WD-40 on it, wipe it down nice, and then I'll put a layer of grease here, just a thin strip, 1/4 inch wide maybe, the full length, kind of rub it in so I know it's good fresh grease. Then I take the Simloop greaser, cut the end off, set the 12 months, screw it in, and now I know I'm good. And then I check the limits. Now, we sell a system, as in your case, because what we want to do is guarantee the performance that you're going to be happy that it does what we said it would. And by providing the pipes, we can do the reducers, the straight diameters to the thermal mass flow meter in the hot tap, then 1 to 2 diameters to our valve, a quality actuator, and then the exit is most important because that's where we're taking care of what's called pressure recovery. And pressure recovery is simply minimizing any recirculation that occurs as that airflow goes through the valve, which causes pressure or pressure drop. Any turbulence is bad. And so by doing this reducer here, now we're taking the flow and we're conditioning it as it's leaving the valve, and we can reduce our pressure drop even further. And here's a sample sheet, very much similar to yours. In your case, we were looking for 10 diameters to the flow meter, 1 diameter to the valve. This is the end of my presentation. It's an ideal time to take questions. Does anyone have any questions? Yes, how can I help?
Sure, so thanks for your presentation. So my first question is about your flow meter. How often do you have to calibrate those flow meters?
I don't see any need to recalibrate it, to be honest. I wouldn't even think of it less than 5 years. If you wanted a number from me, 5 years.
5 years. And how can I verify, the numbers that I'm seeing at the flow meter is correct? And is there any way to verify that number?
Wow, that is a good question.
Because, for instance, the way that for DO probes, for instance, we have a DO probes installed in the bioreactors, and then we have a DO probe, like a handheld, that we can measure and then we can compare the numbers. For nitrate, we can take a sample, we can do some tests in the lab, and then comparing the number that we measured, in the lab versus the number that we have on the probes. I was wondering how can we verify,
So let's start by saying that when I'm selling the features of this valve, I always suggest the customer purchase a flow meter for the purpose of monitoring the flow, trending data, and then if you start losing diffusers, now you know that you have a problem in a drop leg or two. Okay, with that being said, you don't need a flow meter in the process, but I feel that information is power. Now, think about what I just said. Trending of data, yearly maintenance, pulling it out, closing that ball valve, checking it, cleaning it, putting it back in, and that's really all I could suggest. These ABB flow meters are laboratories in Germany, and so to calibrate it, you'd have to send it back to Germany, and I don't see that as feasible.
Right.
So.
The last question that I have is about condensation. You said condensation may make us some problems, so how can we avoid condensation?
Wow. Compressed air begins life at 14.7 psi. And as we compress it down to about 9 psi, you're taking all the air, dirt particles, and moisture that's in this box and shrinking it down to this size. So now the percent of dirty particles, wet particles increases, and that starts to become a problem. So the first thing you want to do is maintain the compressor. Make sure you have good drains on it. I don't know if you have a desiccant or refrigerant dryer. I don't know what kind of drains you have on it to keep the moisture out. But in the nature of how blowers and compressors work, taking air this big and shrinking it down this big, you will have a problem. I don't anticipate you having any problems in the beginning of the pipe, but toward the end of the header, I could see where moisture could build up. Now, what can you do about that? I don't have a good answer other than maintain your blower to minimize the amount of air that the system sees.
Thanks.
Any other questions? Okay, well, great. The next part of the presentation will be Ray Bean from Rotork.
Good morning, I'm Ray Bean. I'm with Rotork Controls, and I'm the Senior Field Service Engineer for New England. Okay, so we're going to go a quick thing on the IQ3 actuators. You have two sizes here, but the basic layout is the same on both. Okay, so the first thing I want to do is you look at this one, because okay, I guess it's not. Can you see that well? Okay, so one of the, I want to say this delicately, issues we have is when customers are putting the unit in manual, okay? So this is your hand auto lever, and the idea is you fully engage the handle and then let it go, and then you can turn the hand wheel, which is now connected to the center column. This is the center column down through here, okay? So this is the sliding coupler. So what this does is when you push that hand wheel down, that lifts this sliding coupler up, and there's a spring here that it compresses. And then this right here is the finger, and it locks in place, and it holds that sliding coupler up so the hand wheel can engage it. Now the way we do this is with dogs. So right here is the hand wheel dog, and then the hand wheel has two dogs in it. The only problem we have is if the two dogs are aligned, so that when you move the sliding coupler up, it hits the dogs on the hand wheel, and you can't fully engage the hand auto lever. So this should be relatively smooth and easy. If you hit a hard stop before then, do not apply more force. Let it go, turn the hand wheel 90 degrees, and then re-engage. And then it should go all the way through, and the sliding coupler will go up and engage. And then you can turn it by hand. Down here, this is a good map diagram also, because this shows you how the motor is engaged. So what happens after you've got it in manual, to get it out of manual and back in electric, all you have to do is run the actuator electrically. So the motor fires up, it starts spinning this, and that finger sits in a groove, and as the brass worm gear here turns, it kicks it off the worm gear. So that finger is actually sitting on top of that worm gear when it's engaged. And there's a groove in there, and that groove will kick the finger out, and then the spring forces the sliding coupler down, and then it engages the worm gear. So neither the hand wheel or this worm gear is attached to the center column. In other words, if you're not engaged, you can turn them and they'll just spin. So the sliding coupler is what engages either to the center column, which is what will go down and drive whatever it's attached to. Let's see. What do we got here? This is just showing the different sizes that we have. And this is the different bases. But you've got simple non-thrusting bases for the most part on the Edgar valves because you're on a gearbox. There's just more stuff on how the bases are. This is the terminal area, and all our outside bolts here are 6 millimeters Allens. So if you want to take apart either the terminal cover or the front cover, it's a 6 millimeter wrench. And this is, you're only going to get in here if you need to rewire something. And you don't have much wires going into or anything. You've only got power and your Profi bus. So if you were going to switch out an actuator, that's the only time you should really need to get in there. Okay, so this is showing how we measure torque. Now, yeah. So if there's something going on in the valve, like it's probably with an air system, it's probably very unlikely, but maybe say some ice formed. And what we do here is, this is a piezo, so it actually measures the pressure that the motor is exerting in either direction by the center column. So the way we measure it, and this is calibrated at the factory, so it knows exactly what percentage torque it is. So when you're setting up your actuator, the common settings, and we'll go over that with that unit. Torque is one of the measurements that you set. And so if it exceeds that limit, then the motor will shut off. That's protecting not only the actuator, but hopefully the valve also.
Ray, can I ask you a question?
Sure.
I believe your torque settings for the factory are at 20%.
No, it's 40 is the minimum.
40 is the minimum.
40 is the minimum.
Okay, Because often in cold weather events, we see high torque, and I think it's maybe the grease gets cold. And so I
Yeah.
found that we raise it up to 65,
Yeah.
and it usually is trouble-free.
Yeah. So you have to do that, and you actually can see how much torque you're pushing because that's a parameter that we capture in the data logger. So when you connect up your laptop to the actuator and download the data logger and the configuration files, you can go in and there's a torque curve that you can assemble, and it will show you the torque, the average torque curve and the torque curve of the last full cycle, open close cycle. So this is the encoder. This is how we keep track of position. It's connected directly to the center column. So either in manual or local, it keeps track. We used to use resolvers, which did a fairly good job, but if the power was out and the battery died, then the resolver didn't know where it was, where the encoder always knows where it is. Let's see. Anything here? This is just showing the outside control knobs. These do not go through the case. They're magnets built into the control knobs. This is the red one is your local remote stop. The black one is your open and close. So there's a magnet in each of those, and on the other side of the electronics cover, there's a board in there that senses what position that those magnets are in, and then relays it to the logic card, which tells you, yes, I'm in remote, or I'm in closed, or I'm been told to go open. And this shows it right here. It was cut off in half. Let's see this. This is just a contactor. It's a regular contactor. One's for going clockwise and the other one's going for counterclockwise. And there's another thing where the maintenance people may want to know is in the terminal block, in the power settings, it doesn't matter where you land your three phases as long as it's on 1, 2, or 3. You know, don't put your phase to ground. But 1, 2, and 3, it doesn't matter what order, because this automatically senses phases and makes a correction so it fires the right contactor when you tell it to go open. But you can change directions too, but that's in the settings. We'll actually look at that too. Let's see. That's just power module. A lot of these have different, you'll never have to get in here because unless you end up changing a power module, and then you just look at the one you took out and make it the same. There's like different jacks depending on what power you want you're bringing in. So if you're, like on this one, if you're at 460, you want to put your jumper on Z. If you're 220, you want to put it on W. It's just a, and it's on this, the wiring diagram. So you always should be able to look at your wiring diagram. Actually, we probably ought to look at this next, because that's all the major components. Let's get out of this. Okay, I did put that in here. Yeah, right here. Okay. So, here's your 1, 2, and 3. What? Solid state module? Get the wrong one. Then maybe 440. So ways. These go into here and they go to your mod. This is from a solid state module. So if you're actually, these might be solid state modules because if they're modulating. So these are used for modulating. Regular contactors are like for just open and close, or ones where you're not going to move them a lot. So, and here's that, this is your jumper, and this is FS1. You guys don't have to worry about it because you don't use them. But here's 4 and 5 on the terminal. These are all the terminal block numbers, the white terminal bung on the back. So 4 and 5 are our outgoing power. And if 4 and 5 get shorted, it blows this FS1 fuse. But the problem is this transformer also supplies power to the logic board. So needless to say, if you short 4 and 5 out, you're gonna blow the fuse and kill your actuator. And it looks like it goes blank and nothing happens, and it looks like a major disaster. But it's not, it's just a blown fuse. Okay, so again, you're not using a whole lot here. The battery is basically only used to power the display, so that when there's no power, the display stays lit. So you can walk up to it and see what position it is. And if you put it in manual and move it, it will show you you're going open and close. The other thing the battery does is if these are set for open and close, if it's like closed and you start opening it, the close limit will go off. It will power these two relays.
Ray, does that mean that we can set our limits for the valve, having no power to the valve, just by using the battery with your Bluetooth?
Yeah, I don't recommend it, but it can be done because it's very laggy. Okay, so first of all, you got to wake it up. So you got to move it a little bit, so the main card comes awake, and then you got to go in and you got to use the infrared only. So that means you have to hold your setting tool right up against the window all the time, and then you have to, press the down key and then wait. Now you got to decide, did it take or is it just too slow? If you hit the down key again, you'll go past where you want to be. It's just real laggy. I mean, if you absolutely have to do it, you can do it. I think on your gates, they set them up with no power using the setting tool. But again, I don't recommend it unless you absolutely have to do it that way. Now the other page of this is your Profibus. This just tells you which you're set up to. Your insies and outsies. It's not major, it's just two things. So your commands come in, go to the main card does it. It talks and tells the Profibus what's going on, and it sends out data out. The one important thing here is 45, your screen. There's a problem. I think we did have this problem here, and we went and fixed them all. What they do is the Profibus it's a shielded multi-cable, and to connect the screen, they just put a piece of braided wire from the screen to 45, and they don't insulate it. Well, in communications, you only want to ground one side, and that side is not in the actuator. That's why we have this device here. So if this is a empty braided, and it gets up against the case, now you've grounded both sides. So you always want to make sure that your screen wire coming to 45 is insulated so it can't ground out against the case. This is for like a high voltage events on the screen, so this will blow and take the voltage to ground. So that's what this is set for. Any questions on the wiring diagram?
How is the Profibus connected to the, how is page 2 connected to page 1? Is it through slot A?
Okay, it's the, the Profibus card is mounted directly onto the logic board, and it's
Sit down the bottom slot A.
yeah, it's there. It's built into the board. The connector is built into the board, so it's not like a loom, like, you know, like here's another one. But okay, so this part right here is the thermal overload, and which is built into the motor. So if this motor gets too hot, this opens, and there's two wires that come all the way down to SK3. Is that SK3? Yeah, SK3 here. Okay, these are physical wires. The Profibus card is a daughter board, and it mounts directly to the logic board. So there's no cables going from the Profibus card to the logic card. Now, does this have a power? No. Because some of the option cards need 24 volts, so there'll be a 24 volt jack on there, and it will go to the power module. Let's see. Your torque sensor, your position sensor, and battery. So like if you get a torque sensor error, you may want to take the cover off and make sure that somehow that this didn't get pulled off. Very unlikely, unless actually on these it's not even likely to do that, because you can turn the cover. On the Mark IIs, the display was built into the main card or logic card. So if you wanted to change it, you had to pull off the main card from its mounts and turn it 90 degrees and put it on. And sometimes the torque sensor would pull off. And then they say, oh, it doesn't work. Well, it's because the cable came loose. So I did that. So the next thing is probably you go to here and show you how to do the basic setups. Okay, so how to connect the setting tool to the actuator, how to get into the settings where you set your limits and your torques. Okay, so how to put the unit into manual. This is a hand auto lever. So we want to turn this. You see it didn't go down all the way. So that was where the dogs were connected. So now that's all the way up. And now you can hear it hitting the dogs. So now if you turn here, you can see that it's moving. Okay, it's closed, clockwise to close, I assume. There. So that's how you engage it. Now to disengage it, we'll put it in local. We move this. Hear that clonk? Okay, so now it went out and it went back open. And now the hand wheel isn't engaged. Okay, so now we'll go about setting up how you set up limits. Okay, this is a setting tool. I don't know if you can catch this, but you see that red light? That's the infrared light. And in this corner here is the infrared sensor. So you got to make sure that the light is hitting the sensor. Going like this isn't going to work it because it's not going to make it.
How far back should it be?
Oh, I usually put it right up here, but you can get up to here. So first thing we want to do is hit the down arrow. and that gets you to this thing, 4 menu screen. And we want the one that it's on. It's called Settings. Okay, so you hit the, now we're connected with Bluetooth because this blue light's on and that blue light's on. So now I don't have to hold it up here. So we're in Settings. So now we want to hit the Enter, which is the center one. We hit Enter, and it comes up to another menu. And the first item on the menu is Limits, which is where we want to go. So now we hit Enter again, and we get another menu. Now the first line here is Direction, and that is when its default is clockwise, but sometimes to close. Okay, so clockwise to close, but some people want it clockwise to open or counterclockwise to close. So you can change it here, but that's only rare, and you know, once it's set up, you should never have to mess with that setting. Okay. The next item is called Action, and that says Limit or Torque. Most of yours should be on Limit. That means that the actuator is going to go to a position that you tell it to and then stop. Okay. Torque is, I'm going to go to that position, keep on going until I reach the torque level that's set on the next line. And that's the torque line. Now, like you said, in the wintertime, you're all of a sudden getting some torque errors. You look here and it's set real low, like 40 or 45. So one of the things you can do is just bump it up a little bit. So you go to the torque line, hit Enter, and it's going to ask you for a password. Unless somebody has changed it, it should be the default, and it should come right up to the screen, which is Rotork. So then you hit Enter again for OK, and it brings you back to the menu screen. And you again have to hit Enter again, and then it will all go dark. So now you use the left and right arrows to change torque. So that's the right arrow increases it, and the left arrow decreases it. And then where you get it to where you want to, you hit Enter, and the new is set. Now this is the open limit, and actually the red light is lit, so we are open. Right? Correct? Yeah, we are open. You can also change your default display or your main display by using the left and right arrows. So here's the big one. It just tells you what the position is. And so that's the open position. So we know it's open. So if we can put it in manual, and you can, like say, we'll just move it down a little bit. Clockwise, right? Okay, so we just moved it down a little bit. So, but this is where we want it to be open. So again, we hit the down arrow, Settings, Limits, and then we move it down to Set Limit, which is the last one in this section, and we hit Enter, and then it comes up and says, move to, oh wait, that's closed. Whoops, we don't want that one. So if now you go here and go Cancel, because it tells you what position, so if you actually get the wrong one. So these are closed settings first, and then the bottom is the open. So we want to go here to Set Limit under Open. Then it says Move to Open and allow for overrun and set OK. So you're sure this is exactly where, what it's saying is make sure this is where you want it to be for open. And then we hit OK. The red light comes back on. That means it's full open. And I must have hit the button again. by mistake. So now if you go back by using the minus button takes you back up the menu. And we're back here, and we're open again. Okay, for close, we'll just take it down to the closed position. Closed. Okay, so again, we'll hit the down arrow, hit settings, hit limits. So say we were having, sometimes it torques out in the closed position because it's seating a little bit too much. So we want to back it off a little bit. The green light went out, so now I know it's not closed. Green light's closed, red light's open. And now we're at close, set limit. Move to close, allow for overrun, and select OK. So we're sure this is where we want to set the close limit. We hit enter, and the green light comes on, and the close limit is set. And that's the close symbol. Green light, close symbol, we're good. The only other thing I want to show you is you can actually, if you're having problems with torque, you can actually see the torque curves on this screen. So again, we'll use the down arrow, and you get your 4 menus, but now we want to go down to this one down here. This is data log. We want to select that, and make sure the time is correct. And it isn't, but I'm not going to set it. You would set that, and you hit OK. Now you've got your torque logs, event logs, trend logs. So let's see, torque logs. We go to valve torque profile. And of course, this is a butterfly valve that's not connected to anything, so obviously you have no torque. But if you had a torque curve, it would come up, show you what percentage it is, and go all the way. So this shows you what's going on with your torque curve. If you're getting one spot, all of a sudden you're getting a spike, you may want to look to see if there's something going on in that position.
So Ray, those torque curves seem valuable to me.
Yeah.
And especially in cold weather events, with the potential of whether it's cold grease or icing or something, if we could match the day to the curve,
okay,
it would be very interesting.
So if the date was set on this correct, you set it correct. If you hook your laptop directly to this and download this data, we have the event log. Now, let's see if we can get to the event log. It's on here also. So you go to the event log and go to error event log, and it gives you the time, place, the time and date right here on the top. And no, I've never done this one. So does this? No. Event. Okay. There's no events here. Scroll. Okay. So these are like all the errors that we do, and then you can jump to the next event, but they must have wiped this out, so there's no events. Which is, event 3. Oh, it's going, event 4. So if you, like at event 4, you go down here on this date, and there should be something that's checked. Something should be checked, otherwise it wouldn't be an event. It's a lot easier on the laptop.
How do you connect the laptop, is that also through Bluetooth?
That's through Bluetooth, yes. It'd be awful hard for me to show you. I suppose I could. Okay, the other important thing is we'll disconnect here. Let's get out of here first. Hit the minus key, get back to the main screen. These only use AAA batteries, and it's because they're explosion proof, and they only allow us to put so much power into one of these things. So it eats batteries when it's connected up. So when you're done, you want to make sure that you turn these off. And to turn it off, you hit the minus and plus button, and it shuts off. If you look at the paper that I have, on the second page, it shows you how to do that. And it shows you a bunch of other shortcuts in case you need them.
Is that how you turn it on as well?
No, to turn it on, you have to connect with the infrared first. So that when I was talking about the infrared, that's when you have to hold it here. So now the blue light's flashing, so they're starting to talk. And let's see, it's taking a while. Oops, didn't make it. There you go.
We've been able to connect every time.
Yep. So yeah, you just got to make sure you hold it there long enough. I obviously didn't because now it's connected. So again, minus plus. So I have done this. So I'm speaking from experience. You're doing here and doing all this stuff and you're connected. The Bluetooth is still on. You stick it in your pocket. You forget to come on. You put your laptop right here, set it up, and your laptop won't find it because it's still connected to the setting tool. So you got to make sure you shut your setting tool off. Okay, I'll get my laptop. So the first thing you got to do is we use Insight 2 to talk to the actuators, and you can get this software from our website, rotork.com. Actually, you can get all this information from rotork.com. You can pick up the wiring diagrams, you can pick up the manuals, the OE, all that stuff is on our website. And it's free. So we go to Insight 2. Okay, so then oops. Don't need that anymore. So I'm going to log in, and you should have, I'll give you the passwords if you need them. So you hit log in, and then the program will fire up. Okay? So then you go up here to connections, discover devices. And if this has been turned on to be discoverable, we should find it. And it doesn't look like it. Oh, there it is. So this will come up. This number is the serial number, okay, of the unit. So, oops. So we want to right-click on, right-click. Hit connect. Okay. And it'll come up with a login. So you're actually logging into the unit. So now it's actually going to talk and transfer data. Okay, so if you want to see what your settings are, you go to your limit, and this will tell you what your torques are set for, and like clockwise or counterclockwise. And you can set limits and stuff right through the screen. If you want to change your torque, you just got a little slider button here that you can change it. And once you get this where you want to, you use the download error or send configuration, so you'd send it back to the actuator.
Ray, that number for torque, is that a torque number or is that a percent?
That's percent. of the maximum torque, which is printed on the name tag.
Do you have a max number that you would suggest?
Me, I don't like, if it's over 80, I start questioning it. Okay, so usually between 40 and 80. Once you get above 80, then it's either something's going wrong with the valve or if it's on a gearbox, the gearbox, or maybe if it's a startup or something that somebody got wrong information and undersized the unit. It's like your car. Your car can do 100 miles an hour, but you don't want to do it for 24 hours a day, So it's the same with an actuator. Yeah, it'll run at 100%, and if you're only opening it once a month at 100%, it will last forever. But if you're opening it 5 or 6 times a day and it's going at 100%, that's a lot of wear and tear. These are designed to fail in the drive bushing. The drive bushing is brass aluminum, and it's designed to fail there. So that will save expensive valves and actuators. Now, when I was talking about, okay, over here we got the data logger section. So you go to the data logger, and again, it hasn't downloaded it yet, and this is going to take a while. So I'm going to, no. Now it's going to fetch the data logger. So before it just looked at grab the configuration, because that doesn't take very long. But the data logger can take about 2 minutes to download. There's right there shows how much where you are in the download. So it does have a bar in case you're wondering, is it broken? You can look here and see if it's moving still.
The bar is at about 40 or 50% right now, correct?
Yeah. If you ever have a problem with an actuator and you want us to help you, take a picture of the nameplate, because the nameplate tells us everything. It tells us what the wiring diagram is, what the serial number is, and we can actually go up and look how it was supposed to be built. So, and another thing would be to take a picture of whatever errors are showing up on the screen. Getting there.
I noticed that you have a long cover and a short cover.
It depends on, because you can have actually 4 option cards at the same time. So if you go more than 2, you need to go to a long cover, because we need more space, especially if you get a big contactor in there. So you go to File, go to Open. So we want to open a configuration, and like I said, I've got tons of them here. So we'll open this one, hopefully. And let's see if event logger. You see, that's weird, huh? So anything that happens, like if somebody comes up to the actuator and moves a knob or it gets a command, it's an event. Okay, we store like 5,000 events or something like that. So right now it's this actuator at this point in time was in remote. It's closed limit, and that's what this S1 is. That's also the closed limit. So you can go over, oh, that's the last one. So we can back up. And here it shows the event date and the event time. So if you have an error, like the actuator stat, if you get a torque trip, this will be checked, torque trip open or torque trip closed, so you'll have the actual time and date. So there's an easy way to find it too, because you're going, oh, how do I find it? So you go all the way to the beginning here, and you get this pull down, And we can go and let's see. I know it's in here. Okay, torque trip open. And then you hit next. Okay, was not, this one hadn't had a torque trip. But you can go to any of these events. Like if I can go to open limit. Okay, and I hit next. So now the unit is open. Okay, which should be open limit. So you can use those pull downs to, so you can keep on going to each open limit. And so you can actually look for torque trips open, torque trips closed. If you know what the error was, then you can go in here, say look for this error, and it will go to that error. And you can find the date and time, and then you can look to see what the temperature was.
Worst case scenario, the date is not set in the actuator. We can just go into it, look for a torque trip, and regardless of the date, we can go and see what happened.
Yeah. Okay. You can see what, it'll tell you what, like over here, this tells you what the position and the torque. So it keeps track of the torque as you go. Let's see, that's full open. It was at 24, 22. See so it does go up and down a little bit depending on weather or how long it's sat, or the multiple reasons. More pressure behind the gate this time than last. So that's how you can go in and actually look. I've solved problems with this. A customer said, well, we actually the valve broke the stem. It's a small valve. And he said, shouldn't have broke. And I go into the data logger, and I find out on that day, when it broke, it had torque tripped 8 times. So somebody kept telling it to go open, go open, go open, go open. It would torque trip. And they knew it was torque tripping because that's one of the errors they were watching for, and they just kept on doing it, and finally it broke.
Okay. Great.
So any other last questions before we wrap this up?
None.
None.
Thank you, Ray.
You're welcome.
This part of the training, I'd like to talk to you about the assembly of a valve. We'll begin with page 1, shows the casing flange, the cover flange, and the adjusting ring. That would be the adjusting ring. That's the part that moves. Here's each side, the casing flange and the cover flange. And as we put it out there, you can see that on this, the casing flange includes these sliding channels. Now those are the channels that are cams right up and down. This part does not move. It's this part that's moving, and the cams fit in these slots. And that takes and moves that along that part, opening the valve. Grease is our friend. So we want to take and grease the channels and these cams or nuts so that when they're placed in here, they move freely. I can give you the spec on the grease. I would hope it would be in our O&M manual. Now, the segments are the blades. And each blade has this bar on here, which is the bar that slides in this groove here. And then on the other side, you'll see that there'll be these nuts. And so you insert these segments into the segment channels, and they're very tricky to kind of fit in place. And you're going to actually put 5 of them in, and then the 6th one's kind of, you got to kind of pull it out and fit it in together because it links together like a puzzle. Here's the casing O-ring that we talk about. Now, our higher pressure valves have 2 casing O-rings. The lower pressure, below 90 psi, have 1. Your O-ring material is Viton. It has a single O-ring. So you would then take these components, properly greased, you'd put them into here and see how these are the blades fully extended out, and then they will link together like the puzzle. And now you can pull it together and see how we're starting to close this. So this is the cover flange. You need to grease the raised machine area, this part right here, for the segments to slide on. Also the grease #1 O-ring channel. See this O-ring channel? So what's the wear parts? The O-ring and of course grease. Theoretically, none of this is exposed to the air, so the grease shouldn't go away, shouldn't have a problem. Now when we're building a valve, we also put grease on the valve segments, and that's a special grease to withstand the moisture and the temperature changes. And now as we start to put it together, you can see it's in this casing ring against one side. I forget if that's the cover, the casing cover, and then the ring. And these are those bars with that cam that as you're rotating, it's pushing those bars in that groove. Now that's the final side. Grease it, grease here, then you can flip it over and bolt it together. And then we use anti-seize on the bolts. The bolts come through the body like this, tighten it to 50 foot-pounds. We use a torque wrench. And do not just tighten one. You can crank down on it, tighten them a little bit at a time. So maybe go diagonally, you know, from here across to there, to there, to there, to there, to there. And then tighten them at 5 pounds, and then 20 pounds, and 40 pounds.
Is there a spacer in there? Is it like a sleeve?
So on the nut, or on this bolt here, there is a sleeve. Now this is the, I call it a rack and pinion system. It's the spindle mounting system. And so these are some of your components here. This is the side body of it. This is the flange that mounts the Rotork actuator. And they're saying scrape away any paint that accumulates here. In your case, it's stainless steel, so it should be clean. It must be clean. It has to be clean. The sleeve needs to be inserted in here. And this is a sleeve for that spindle assembly to go through. And it's this spindle assembly. So what we're looking at is this part here, which is this part. And then we have a bushing in there too. And then that spindle assembly goes through, and then here's the bronze nut. And what's so critical is with the Rotork actuator, setting these limits so that it's not over thrusting and breaking the nut or stripping the nut. And I have this problem every time I don't send a service guy out to set the limits. I can predict there'll be a failure because those limits don't get set right. Now Ray said something, and I don't know the correct terms, but Ray said something where you would by hand turn his actuator until this nut very gently touches that surface, and then we back it off. Maybe 3/4 of a turn or a turn.
Yeah.
Would that be okay?
Yeah.
And then we set that as the limit. And then when we go to this side, we do the same thing. Comfortably till it touches, back it off a turn or two. Now, the beauty of the Iris valve is that we have this spindle assembly, and so our smaller valves are about 28 turns to open, 28 turns to close. The larger valves can be as much as 60 and 80. So that's why we use the IQM series Rotork. The IQM, the M stands for multi-turn. And so it's not a 90-degree open-closed, it's multi-turn. In this case, it's many, many turns. And so when we exercise the valve, we like to exercise it once a year when we change the Simlu greaser. And we'll either do it by hand, which we prefer not to do, or electrically exercise that valve 3 or 4 times. And that way we get everything moving. If the valves tend to sit for more than a month, I would exercise them. So now we're assembling these components, and the following two photos show the sides of the wear washer. And this would be one side, and then if you flip it over, that's the other side. And that wear washer is a component that then we apply grease to, and we fit it into there. And that's the other side. And then that's greased. But you should not be bottoming out that nut. If you bottom out that nut, the grease is there to help, but it's not going to save that nut. And then again, grease on the surfaces. And then as we assemble it, more grease placed there. This is a transmission shaft locking ring. And the way you set that is remove the bolts, and then you can pull it apart. And take notice how the two pieces go together, and that both of the tapered edges are facing away from the drive assembly. And then that gets mounted on the side here. You screw the larger part into the end of the transmission shaft, tighten it finger tight. After you've tightened it finger tight, use a pin to back it off a quarter turn. So now that's locked onto this casing, or this flat flange. And then what you do is you take this secondary nut and thread it on, and then you use a shim about a 1/16 of an inch or 2 millimeter spacing, tighten it there, and now it's set. And so that's the setting up the play or the movement of the shaft itself. Loctite, and then you Loctite the bolts into there. That's a good picture there. This is where the sim lube greaser attaches. Here's your pointers or indicators. They can become bent. You might have to reset them. Just bend them with the pliers. And what we're doing is we're just setting the pointer so it reads 0 there or it reads 100 there. That's all we're doing. And then final installation. And then mounting the Rotork. There's our valve fully closed. The measurement of pointers. Setting those pointers. The sim lube greaser. An Allen wrench goes in there, sets it for 12 months. There's a, well, I'm not showing it, but there's a piece that comes off that's threaded, then you cut the end off. You set it for 12 months, screw it on. And that's it. Great. Well, thank you for the suggestion of showing you this part of the presentation. I've never done that before, but I think it's a great idea. Thank you very much.